Hi everyone, in this video I'm going to talk about dangerous AC adapters. So these things are actually called lots of different names. AC adapter, some people will say it's a charger, some people will say it's a power supply, and it technically is all of those things. But essentially you would charge tablets or phones or whatever using this, or you'd power them, whatever. So you plug that into the socket, the wall socket, and on the other end you plug in a USB cable, and on the other end of that you'll have micro USB like this, or mini USB or whatever. So essentially the thing's very easy. It simply charges a tablet or a phone or whatever. So this one in particular is my phone charger, and it's made by HTC. Well, actually I'm not sure if it's made by them, but it's certainly branded HTC. And yeah, this is a phone charger. So if we have a quick look to see what it actually says, it says AC adapter, and then it says a model number, and then it says something which I don't understand, and then it says input 100 to 240 volts AC. That little squiggle means AC, and then it says 200 milliamps. That's how much current they expect to input into the device, and it says 50 to 60 hertz, which is the amount of waves per second for AC in the country that it's used in. This is designed for 50 to 60 hertz. So then it says output 5 volts, 1.5 amps. So 5 volts is the voltage, and that's standard USB voltage, and current, it can allow current up to 1.5 amps rated. That's pretty straightforward. Now, if this was to go wrong, it could be dangerous, because of course one side is on mains voltage, and that's very high. The other side is low voltage, 5 volts. It can't really do any harm. Well, it certainly can't do any harm in terms of voltage. It could still potentially cause a fire or whatever, but I'm not going to go into that. There'd have to be some sort of major problem for that to happen, and I'm not going to go into that. But anyway, the major problem, if this was to go wrong, is on the mains side. Now, before I show you exactly what the problem is with this and why this is extremely dangerous, I think it would be a good idea to firstly show you why, or to maybe go into it a little bit more as to why this is potentially very dangerous. So I'll just bring a piece of paper over. And the reason why it's dangerous, or particularly dangerous to humans in terms of voltage, is because it allows a high amount of voltage to be accessed, if you like. So in the UK we have a voltage of 240 volts, we say, RMS. And in Europe they have 220 volts RMS, and in America I'm not 100% sure, but I think they have 110 or 120 volts RMS. So if I just draw a diagram here, it's actually a little chart. I'm going to do this off the UK. Oh, by the way, there's another standard as well. So there's 220 volts, which is the EU, and there's 240 volts, which is the UK. It's actually a standard 230 volts, and that's how a lot of these appliances are made. They're made for 230 volts. And the reason for that is because what they've tried to do is they've tried to merge the EU standards with the UK standards. So UK 240, EU 220, so they thought, well, let's do 230 and it should work with both. Anyway, just an interesting fact. So, getting to the point again. So let's try and draw a wave. So there's a wave. Now, we can analyse this in different ways, but if I just put some ticks here, or some marks, this here represents 0 volts, and we have 240 volts in the UK, which is around about here. Now you might find this a bit odd, that 240 volts would be here. I'll just write 240 volts. So that's a high amount of voltage, and it can of course kill. Right, but there's something which is commonly misunderstood, and that's something called RMS, which means root mean square, which I won't go into that too much, but essentially this 240 volts here is RMS. And it's not actually the amount of voltage which goes through our sockets. The voltage that goes through our sockets can be a lot higher than that, and it can actually be, if I just mark it here, this point here is near 300 volts. 300 volts. But yeah, the reason they say 240 volts is because it's RMS. It's an averaging concept, if you like. So the average voltage that runs through this wave averages out in that certain way at 240 volts. But yeah, the actual peak is 300. This is called the peak here, and the trough, which is here, is actually minus 300 volts. So you could say that the maximum voltage between the two is 600 volts, because voltage is also called potential difference. It's a difference between two voltages. Anyway, so the total difference between the two is 600 volts. But anyway, if we just say 300 volts is the max, essentially what it means is that if you were to touch the live terminal in your mains, in your socket or in your house, you would have you'd have 300 volts to minus 300 volts whizzing through your body, flitting in and out extremely fast. That would happen 50 times per second. So yeah, so we say 240 volts, actually 300 and minus 300 whizzing up and down really fast, and that is deadly. If you were to touch that and it was to pass through your heart or something, you would, it wouldn't do you any good, let's put it that way. So yeah, anyway, why am I going into all this detail for something to do with faulty AC adapters? Well, I just wanted to highlight that this is extremely dangerous. I mean, to have this sort of voltage pass through your body is extremely dangerous. Anyway, so let's get on with the actual video. So here's the adapter again, the AC adapter, or whatever you want to call it. And this is the problem. Now, a few days ago, this was plugged into one of my sockets, and I've got two little girls, and I don't exactly know how this happened, but I assume what has happened is that this thing was plugged in like this, and someone had simply pressed on this part here, and this is why it's extremely dangerous. It simply comes off just like that. Now I assume this sort of design is supposed to be glued. You can see that there's a very, I think it's quite poor, like it's like a little flange. Anyway, so that goes in there like that. Yeah, there's a little bit of glue, and that's it, they say job done. But anyway, it's extremely dangerous because this just simply breaks off or pulls off, or well, I assume breaks off. This breaks off and exposes all the components inside. Now, this is extremely dangerous because when I went into my room, this was plugged into to the socket, and of course you wouldn't see that, it's just this that sticks out. And one of these here, it will be this one, is live. So that's plugged in, the thing was switched on, and that piece of metal there is a dead short straight to live in the house, in the wiring of the house, which would be flicking between 300 and minus 300 volts 50 times a second, which is deadly. So yeah, this AC adapter is extremely dangerous, and in my opinion it's not been very well designed. This was simply left in a socket just like that, so that if anyone was going to touch that, they'd quite literally get the shock of their life. So yeah, extremely dangerous. But while we're here, let's just find out what's going on here. So this pin here would go to live, which is the voltage. This pin is the earth connector, but it's plastic, so it's not actually used. In the UK, you have to use these, whether you like it or not. If the thing doesn't actually use earth, you've got to provide an earth pin anyway. And the reason for that is in the UK, we have these safety connectors, and basically if you were to just push those two pins in, it wouldn't physically go in, because there's a lock-in mechanism, and it's built into the switches. I think it's probably a British standard, and yeah, if you don't use that, the locking mechanism won't let you connect the other 2 pins in, so I suppose that's quite cool. Anyway, so that's that, and this is of course neutral. So yeah, this is live, goes through the circuit, does whatever it needs to do, and this here, neutral, provides a path to be able to complete the circuit and therefore let the thing work. Anyway, so over here, I can't remember which way this was now, yeah, it's that way. So from live here, it goes through the circuit and it will go through something called a bridge rectifier, and the bridge rectifier will make it into DC, because this is, you know, phones and all that are DC devices, usually 5 volts, and that's usually used to charge a 3.7 volt lithium cell, usually. So yeah, it would go through that, and it would probably go through something called a switch mode power supply, which, you know, doesn't necessarily do it in this order, but it would usually rectify and then it would step down, or sometimes step down and then rectify, it depends. And of course step down is getting the voltage which has been rectified and stepping it right down to 5 volts, because obviously if it wasn't rectified, if it wasn't stepped down, it would completely blow your device up. So yeah, AC gets converted to DC, and then the high DC voltage would then get converted to a low DC voltage, or the other way around. So anyway, that's what's happening in there. You can actually see a little switch mode power supply in there, switch mode transformer. Anyway, so that's that. So if you've got any of these devices, you might want to check that to see if these things are actually designed properly and if you feel they're safe or not, because yeah, look at this, it's that easy. And I suspect probably my 1-year-old did this, or maybe the 3-year-old, and they were certainly playing in the room while this was in that state, which is extremely dangerous. Anyway, that's that. Thanks for watching. Bye.